Hello and good morning or good afternoon or good evening. I'm going to be going over some more exponent rules, specifically when you have a fraction as an exponent. Try to follow along, work your way through. If you're having trouble, just be sure to pause and slow down, go back and make sure you're understanding it. Alright, let's get started. First, I just want to go over a few rules really quick. X to the 1 is the same thing as x. X squared is the same thing as x times x. We also know our power to a power rule, which means x to the m n is equal to x to the m times n. So let's suppose, for instance, I have x to the 1/2 times x to the 1/2. That's going to be x to the 1/2 squared, which is equal to x to the 1/2 times 2. 1/2 times 2 is equal to 1, so we've got x to the 1. Now let's take two different parts of that. We'll take our x to the 1/2 squared is equal to x to the 1. And if I wanted to get rid of this square right here to get just the value of inside the parentheses, I've got to undo it. I'll just take the square root of both sides. These knock each other out, and what I get is x to the 1/2 is equal to the square root of x. So there you go. X to the 1/2 is the same thing as the square root. And similarly, along those lines, suppose that we have x to the 1/3. That's going to be the cubed root of x. If I have x to the 1/pi, it would be the pi root of x. So you can do all kinds of things. So we'll make our note up here, square root of x. And let's take a look at a to the 2/3. So a to the 2/3, and we can do the reverse of the power to a power rule. We can do a squared to the 1/3. Well, that looks a lot easier. We just know that it's a squared and the cubed root. And you can also write that as the cubed root of a squared. It's the same thing. You can do it either order. Pretty easy stuff. Taking a look at this example right here, I have the 4th root of beta cubed. So the 4th root, that's going to be beta to the 1/4 and cubed. And remember your power to a power rule, that's going to be 3 times 1/4, or 3/4. So that is beta to the 3/4. Not too difficult. Let's move on to skill 8. Okay, looking at skill 8, we've been given quite the problem, but fortunately with math we know how to solve our problems. The first thing we want to do is combine like terms where we can. That's going to be this x right here. I just want to subtract an x from both sides. Now we've got the square root of x minus 1 is equal to 3x plus 5. And we can't do much moving forward from here until we get rid of the square root. So what I'm going to do is square both sides. That way these cancel. I'm left with, whoops, that was a minus x. I'm left with a minus x minus 1 is equal to 3x plus 5 times 3x plus 5. And doing all of the math out, we have a negative x minus 1 is equal to 9x squared plus 15x plus 15x plus 25. To combine like terms, that's going to be bringing this x over and this 1 over by putting it on both sides, which gives us 0 is equal to 9x squared plus, and I'm going to combine this 15x, and 1x. That gives us a 31x plus, and right here gives us a 26. And that's great. We can work with this and factor it to find a solution. Let's bring it over here so we can fit in more work. The easiest way to factor this is going to be by grouping. So I'm going to have to split up this 31x to form my groups. We'll take a 9x squared plus 13x plus 18x plus 26. This will be my first group, and this will be my second group. We'll take an x out of this group, our first one, leaving us with 9x plus 13 plus, and we'll take a 2 out of our second group. That's going to be a 2, and that leaves us with 9x plus 13. And you might notice this is sort of like the working out the distributive property. This x plus 2 is our first part, and this 9x plus 13 is our second part. So you'll see the x plus 2 has been distributed. Up here we're just reversing it. Here's the x times 9x plus 13, and then the 2 times 9x plus 13. So that's just the reverse distributive property if you're wondering how we got there. Okay, now in order to find our solutions, we'll set both parts equal to 0. There's our x plus 2 equals 0, and 9x plus 13 equals 0. I'll subtract 2 from both sides on this one. We have x equals a negative 2, and over here I'll subtract 13. We have 9x equals a negative 13. If I divide both sides by 9, I'm running out of room here, we have x equals a negative 13 over 9. What's really crucial when you work on these problems is you need to check your answers. Because we squared both sides, it can give us certain terms that won't work out the way that they would underneath the square root. So let's go ahead and check. Negative 2 minus 1 plus 2 is equal to 4 times a negative 2 plus 5. Sorry, that needs to be a negative 2 because our x value is negative 2. So I missed that one. And negative negative gives us a positive. So a positive 2 minus 1, we're left with the square root of 1, which is also just 1. Minus 2 is equal to negative 8 plus 5. 1 minus 2 is a negative 1 is equal to a negative 3. Well, that's not true. So we know that x equals negative 2 is not a valid answer. How about a negative 13 ninths? We'll take the square root of a negative 13 ninths minus 1 plus negative 13 ninths is equal to 4 times a negative 13 ninths plus 5. And if you do all of that math out, you get a negative 0.7 repeating is equal to a negative 0.7 repeating. That one checks out, which means it is a valid answer, and we'll just write it right here. Fantastic. There you have it. So I hope this helped. Any comments or feedback is more than welcome. And remember to breathe, stay home, and stay engaged.